And when I ask you about how many solutions this equation had, so can I say that there are infinite points which are lying on this particular equations? So if there are infinite points which are lying on this equation, so this equation had the infinite solution. But if I ask you, instead of finding the number of solutions, how many non-negative integral solutions are there? How many non-negative integral solutions are there for this equation? Or this is also known as the whole number solution. Also another thing is how many positive integral solutions are there. Or we can say the natural number solution. Now, when we are supposed to find out the non-negative integral solutions or the positive integral solutions, okay. So remember here the answer is not infinite, because if I am talking about the non-negative integral solutions, so it will always lies between from here to here in the first quadrant itself. Okay. All the values non-negative means including 0. So basically we have to find out the solution which are lying on this particular line. Okay. So for finding the non-negative or positive integral solutions, what we are supposed to do is here, can I write down this equation as 5x is equal to 150 minus 3y? Or x is nothing but that is equal to 30 minus 3y by 5. Now, here we can say that for x to be an integer, the value of y by 5 should be also an integer. So the different possible value of y by 5, we will start with 0, because in that case 30 minus 3 into 0 is 0, and 30 minus 0 will give me the value of x, which is 30. The next possible value of y by 5 is equal to 1, 3 into 1 is 3, and 30 minus 3, that will give me 27. So let's say if I write down the values of x, here it is 30, then it is equal to 27. If I put the next value of y by 5 as 2, that is 3 into 2, 6, and the value of x is nothing but that is 24. Okay. So, if I follow the same procedure, maximum value of y by 5 is 10, because 10 into 3 is 30, 30 minus 30 is 0. I cannot take the value of y by 5 as 11, because if I take it as 11, 3 into 11 is 33, and 30 minus 33, that will comes out to be a negative. And we are supposed to find out the non-negative integral solution. So at the max, the value of y by 5 can be equal to 10. And when y by 5 equal to 10, we'll get the value of x as 0. Remember that these are the value of y by 5 and these are the value of x. Okay. Now when y by 5 is 0, y is nothing but that will comes out to be 0. When y by 5 is 1, y is equal to 5. When y by 5 is 2, y is equal to 10. And when y by 5 is 10, the value of y will be equal to nothing but that will comes out to be 50. So if I look at here, the different values of y are from 0 to 10. So 0 to 10, if I count here, there will be a total of 11 solutions. So the number of non-negative integral solutions will be 11. Okay. And the number of positive integral solutions is nothing but that will comes out to be 9. Why 9? Because out of these 11 cases, in the first case the value of y is 0, and in the last case the value of x is 0. So out of these 11 cases, in 2 of the cases we are getting a whole number. So we have to find out the positive integral solution. So 11 minus 2, that will give me the value of 9. Now the most important thing when you are discussing this, how to find out the non-negative integral or positive integral solution, is that if you observe this equation, this entire solution, here the value of y, it keeps on increasing at an interval of 5, whereas the value of x, it is decreasing at an interval of 3. Now it's again a very important observation. What I can say here, it is nothing but the change of coefficient. If you look at here, the value of x, it increases at an interval of 3, and the value of y, it is changing at an interval of 5. So this is one of the important observations, and please tell the students to remember this thing also. That for example, if there is any equation like ax plus by equal to k. So once I find out the smallest value, the value of x will always change at a gap of b, and the value of y will always change at a gap of a, depending on the equations here. It is quite possible that both the values are increasing or both the values are decreasing, or if one of them is increasing, the other is decreasing. It depends on the different types of equations here. Now once you discuss this equation, you can take a couple of more examples from this particular non-negative and positive integral solutions from the class exercise. There were 2 to 3 questions were there in the class exercise from this particular topic here. And one of the CAT questions which you can take, that is 4x minus 17y is equal to 1, where we are supposed to find out the integral number of solution if the value of x is lying between 0 to 1000. Just discuss this question with the students also. Now, and when we are discussing the non-negative integral solutions and the positive integral solutions, we can also discuss a question like this one. If I say x plus y is equal to xy. Okay. And how many integral solutions are there for this equation? Okay. Now remember that here, one of the methods for finding the integral solutions we have discussed right now, that is with the help of the linear equations here. Now this is also a linear equation, but here the funda of the number system is used to find out the total number of solutions of the equation like this one. What I can say that this is basically xy minus x minus y is equal to 0, or if I take out here xy, x is common, I will get y minus 1 minus y is equal to 0. Okay. Now add 1 on both the sides. Add 1 on both the sides. So from here I will get the value that x minus 1 into y minus 1 is equal to 1. And now this question is simply, in how many ways the product of two integers is equal to 1. Okay. And we know how to find out in how many ways any number can be written as a product of two numbers, because we have discussed this thing in the number system itself here. So this 1, it can be either written as 1 into 1 or minus 1 into 1. Okay. So it means there are only two possible solutions. From here we get the values of x and y, okay, which will comes out to be x is equal to 2 as well as y is equal to 2. Okay. And from here I get the value of x and y as nothing but x equal to 0 and y equal to 0. So it means there are only two values, two integral values which will satisfy this equation here. Okay. So it is again the application of the number system in the algebra. Okay. And maybe you can give a couple of more example or for the homework to the students, like x plus y is equal to xy plus, you can say that is 99. Okay. Maybe you can give it to homework, they will solve the questions, and maybe you can discuss it in the next. So these are nothing but the application of whatever we are discussed here right now. Okay. Now after the integral number of solutions, just go to the very basics. If I say, let's say the linear equation is nothing but it is in the form of a1x plus b1y is equal to c1. The other linear equation is a2x plus b2y is equal to C2. Now these are two simultaneous linear equations, and how to solve these two simultaneous linear equations? Now here there are three different possibilities. The three different possibilities are, because this is one line and this is another line. So if I plot the graph of these two equations, okay, that is quite possible that both the graphs are intersecting at only one point. Okay. Now if they are intersecting at only one point, so it means that is a unique solution. Okay. So this particular graph is with respect to the unique solution. Okay. And the condition for the solutions to be unique is A1 by A2